Here's how to solve a 1D projectile motion problem in physics. So in this example, we have a ball being launched directly upwards, and we're asked to figure out the maximum height it reaches, as well as the total time the ball spends in the air. Now, I know these problems can look kind of scary, especially when you have a massive formula sheet and no clue which equation to use. But here are some quick tricks to make it easy. Anytime you see distance, velocity, or time in a problem, you're probably going to want to use one of these 4 formulas, which we call the kinematics equations. Special note, delta x in these equations just refers to the change in position in one dimension, not the specific direction of that dimension. So while x usually means only going to the left or right, in our problem we're just dealing with the up and down direction. So you can think of the delta x as a delta y if that makes it easier. Anyways, the trick to knowing which equation to use is to see what variables are given in the problem and which one you're trying to solve for. In the first part of this problem, we're given the initial velocity, 20 meters per second, and we're trying to solve for the maximum height, which is the change in position from the ground, or delta x. The last bits of information we were given that might not be obvious is that the final velocity is 0. This is because when the ball is at its maximum height, it will have 0 velocity in the y direction. Also, the acceleration in the y direction is negative 9.8 meters per second squared, because any projectile moving freely in the air always experiences a downward acceleration due to gravity. So going through our formulas, we want to use the kinematics equation that has initial velocity, final velocity, acceleration, and the change in position. You can notice that each formula has a different variable missing, so if we're not given and we're not solving for that missing variable, then that's the equation we want to use. Which for the first part of this question, to find maximum height, we're not given, nor are we trying to find the time t. So we're going to use this third equation to solve our problem. All that's left to do is to plug in the numbers, do a little algebra to solve for the unknown change in position, and you'll find that the ball reaches a maximum height of 20.4 meters. Now let's try to find the total time that the ball stays in the air. Technically, there are a couple different ways you can solve this, but we're going to use a quick trick where the total time an object stays in the air is equal to twice the amount of time it takes for the object to reach its maximum height. Warning, this trick only works if the starting and ending height of an object are the same. Which, since our ball starts on the ground and ends on the ground, we're all good. So solving for the time it takes for the ball to reach the maximum height, we know the initial velocity, the final velocity, and the acceleration due to gravity. Looking at our formulas, the only one that has what we're solving for, time, and what we're given, initial velocity, final velocity, and acceleration, is this first one. Now all that's left to do is to plug in the numbers, do a little algebra to solve for the unknown time, and you'll find that the ball reaches a maximum height in 2.0 seconds. Which, if we double it to get the total time for the ball to get back down to the ground, is 4 seconds. And there you have it.